Welcome. Every system starts small, but demand rarely stays that way. In this lesson, we are going to look at scalability, what it actually means in architectural terms, the two main strategies for achieving it, and the design decisions that make the difference between a system that grows gracefully and one that buckles under pressure. Imagine you launch an app and it works beautifully. Then it gets popular. Response times double, errors appear, and your database becomes a bottleneck. You upgrade the server and it helps briefly. Then the problem comes back worse. This pattern tells you something important. Performance problems at scale are almost always structural. The architecture was never designed to grow, and no single hardware upgrade will change that. This analogy captures the central tension in scalability perfectly. A faster machine has limits. There is only so much one person can do. But adding more stations means customers can be served simultaneously, and you can keep adding stations as demand grows. The same logic applies directly to software systems, and which approach you choose has deep architectural consequences. A well-structured system separates concerns into three tiers. The presentation tier receives incoming requests. The business logic tier decides what to do with them, applying rules, calling other services, computing results. The data tier persists and retrieves information. This separation is not just tidy design, it is the foundation of scalability, because each tier can be reasoned about and scaled on its own terms. Follow a single request through the system. It arrives at a load balancer, which distributes it to one of several application servers. This distribution is horizontal scaling at the presentation and logic tiers. That server runs the business logic and then calls the database. The database is the final stop, and it is the hardest tier to scale horizontally because it holds shared, persistent state. This is precisely where most scaling bottlenecks live. Vertical scaling is the quick win. You resize the machine and move on. It is ideal for databases and other components where shared state makes distribution difficult. But every machine has a ceiling, and you are still one failure away from an outage. Horizontal scaling removes the ceiling and adds resilience, but it demands that your components be stateless. Each server must be able to handle any request without relying on local memory from a previous one. The single most important decision you can make for horizontal scalability is to keep your business logic tier stateless. That means any server can handle any request because no local state is required. Sessions, tokens, and user context all live in a shared cache or database. Once that is true, adding more application servers behind a load balancer becomes trivial. The data tier is the last frontier. Start with vertical scaling, add read replicas for read-heavy workloads, and lean on caching to protect the primary database. Scalability is not a feature you add later, it is a property of the design. Systems that separate concerns into clear tiers, keep their logic stateless, and protect their data layer with caching and replication can absorb enormous growth with straightforward additions. Systems that tangle these concerns together hit walls that no single hardware upgrade can move. Design for scale from the start, and growth becomes an operational problem rather than an architectural crisis.